Hey there, space enthusiasts! Get ready to have your mind blown with some of the craziest and most entertaining facts about our solar system. From the scorching heat of Venus to the icy depths of Neptune, we'll be exploring the wonders and mysteries of our cosmic neighborhood. Let's embark on this incredible adventure together. Our Sun, a blazing ball of plasma at the heart of our solar system, is so gargantuan that it beggars belief. Imagine 1.3 million Earths mashed together. That's the volume of our star. It's the solar system's heavyweight, over 99% of its total mass. Its energy from nuclear fusion bathes our planet in light and warmth, a dynamic cauldron of activity with solar flares and coronal mass ejections. Venus, our closest planetary neighbor, often shrouded in thick, swirling clouds, might seem like a twin to Earth at first glance. But don't be fooled. This is one scorching hot world, with surface temperatures that could melt lead. Venus is even hotter than Mercury, despite being farther from the Sun thanks to a runaway greenhouse effect. Venus's dense atmosphere, choked with carbon dioxide, traps the Sun's heat, making it a veritable planetary oven. It's a stark reminder of the delicate balance that keeps our own planet habitable. Imagine a world where a day is longer than a year. This planet has a mind-bogglingly slow rotation, taking a leisurely 243 Earth days to spin once on its axis. But here's the real head-scratcher. Venus zips around the Sun in just 225 Earth days. This bizarre phenomenon is likely due to a cataclysmic collision in Venus's past, which knocked it off its original axis. In the swirling clouds of Jupiter, the largest planet in our solar system, rages a storm of epic proportions, the Great Red Spot. This colossal anticyclone, a swirling vortex of crimson hues, has been raging for at least 4 centuries, possibly even longer. To put its size in perspective, imagine swallowing Earth whole. Though it has shrunk somewhat in recent decades, it's still large enough to be visible through even modest telescopes. The Great Red Spot is a testament to the raw power of nature, a swirling reminder of the forces at play in our universe. Saturn, the celestial showman, adorned with its magnificent rings, a cosmic halo that has captivated stargazers for centuries. Imagine countless particles of ice and rock, ranging in size from tiny grains to massive boulders, all orbiting Saturn in a graceful ballet. Despite their vastness, these rings are incredibly thin, like a cosmic razor blade, spanning hundreds of thousands of kilometers wide but only a few tens of meters thick. Uranus, the ice giant with a rather unusual quirk, is a planet that marches to the beat of its own drum. Unlike its planetary siblings, which spin like tops around the Sun, Uranus is tilted on its side, rotating almost perpendicular to its orbital plane. This extreme tilt gives Uranus the most extreme seasons in the solar system. The prevailing theory suggests that it experienced a colossal collision with a planet-sized object early in its history, knocking it sideways. Neptune, the icy giant in our solar system, is a world of extremes. Shrouded in azure hues, it has the most ferocious winds, reaching over 1,200 miles per hour. These winds whip up massive storms, including the Great Dark Spot, a vortex that dwarfs Earth. Scientists believe Neptune's internal heat and rapid rotation drive these extreme winds. Pluto, the little celestial body that could, or rather couldn't quite cut it as a full-fledged planet. Once considered the 9th planet from the Sun, Pluto was reclassified as a dwarf planet in 2006, sparking controversy and debate that continues to this day. But don't let Pluto's demotion fool you. It's still a fascinating world, a resident of the Kuiper Belt, a region beyond Neptune filled with icy bodies and dwarf planets. Between the orbits of Mars and Jupiter lies a region teeming with celestial wanderers, the asteroid belt. This cosmic shooting gallery is home to millions of asteroids, ranging in size from small pebbles to dwarf planets hundreds of kilometers across. The asteroid belt is thought to be leftover material from the formation of the planets, prevented from clumping together into a planet by the gravitational tug-of-war between Jupiter and the Sun. While most asteroids are harmlessly minding their own business, occasionally, one gets nudged out of its orbit and sent hurtling toward the inner solar system. On the dusty, rust-colored surface of Mars lies Olympus Mons, the largest volcano in our solar system. This behemoth dwarfs Mount Everest, towering at 13.6 miles high. Its base would cover Arizona. The caldera is vast, fitting Los Angeles several times over. Olympus Mons is a shield volcano formed by slow lava eruptions over millions of years. Beyond the orbit of Neptune lies a frigid realm, a vast, donut-shaped region populated by icy bodies and dwarf planets, the Kuiper Belt. This celestial treasure trove is home to trillions of icy objects, remnants from the early solar system preserved in a deep freeze for billions of years. The Kuiper Belt is thought to be the source of many comets, which are flung inward by gravitational interactions with the outer planets. Imagine a vast, spherical shell, enveloping our solar system like a cosmic bubble extending trillions of kilometers out into interstellar space. This is the Oort cloud, a theoretical region of space thought to be home to trillions of icy objects, remnants from the formation of our solar system. The Oort cloud is so far away that its objects are only loosely bound to the sun's gravity, making them susceptible to gravitational nudges from passing stars or galactic tides. Mercury, the smallest planet in our solar system and the closest to the sun, is a world of extremes. With its scorched surface and lack of atmosphere, it experiences the most dramatic temperature swings of any planet in our solar system. Imagine a world where the sun blazes with unrelenting fury during the day, baking the surface to a scorching 800 degrees Fahrenheit, hot enough to melt lead. But as soon as the sun sets, the temperature plummets to a frigid minus 290 degrees Fahrenheit, colder than the coldest night on Antarctica. The sun, our local star, is not just a source of light and warmth, it's the gravitational anchor that holds our entire solar system together. Its immense gravitational pull keeps all the planets from tiny Mercury to giant Jupiter in orbit, dictating their celestial dance around the solar system. This gravitational balance is what keeps our solar system stable, preventing the planets from flying off into the depths of space or spiraling into the sun. Our solar system is home to a vast collection of moons, natural satellites that orbit planets and dwarf planets. These celestial companions range from tiny potato-shaped rocks to worlds larger than Mercury. Some moons, like Europa and Enceladus, have oceans beneath their icy shells. Others, like Titan, have thick atmospheres and lakes of liquid methane. Our solar system, a cosmic oasis teeming with planets, moons, asteroids, and comets, wasn't always the well-ordered place it is today. It was born from a chaotic cloud of gas and dust roughly 4.6 billion years ago, a swirling nebula that collapsed under its own gravity, igniting the sun at its center. Over millions of years, dust grains clumped together, forming larger and larger objects, eventually becoming the planets and moons we know and love. Streaking across the night sky, leaving a trail of cosmic dust in their wake, comets are among the most captivating celestial objects visible to the naked eye. These cosmic snowballs are remnants from the early solar system, icy relics that hold clues to the conditions that prevailed during our solar system's infancy. As a comet approaches the sun, its icy nucleus heats up, releasing gas and dust that form its characteristic tail, which can stretch for millions of kilometers. Our sun isn't just a source of light and warmth, it's also a cosmic powerhouse, constantly emitting a stream of charged particles known as the solar wind. This solar wind, a constant outflow of plasma, inflates a bubble-like region of space called the heliosphere, which envelops our entire solar system. The heliosphere acts as a shield, deflecting and slowing down most of the harmful cosmic rays that would otherwise bombard our planet. Launched in 1977, the Voyager 1 spacecraft is a testament to human ingenuity and our insatiable thirst for exploration. This intrepid explorer, carrying with it a golden record containing greetings, music, and images from Earth, is the farthest human-made object from our planet, having crossed the boundary of our solar system and entered interstellar space. Voyager 1 continues to beam back data from its journey, providing us with unprecedented insights into the interstellar medium, the space between the stars. Thanks for joining us on this incredible journey through our solar system. Like, subscribe, and hit the bell for more mind-blowing content. Until next time, keep looking up. There's so much more to discover in the vast universe, so keep exploring and keep your sense of wonder alive. The cosmos awaits.